video lecture we'll be solving this problem map of highest peak. So which is a Leetcode medium problem. In this problem we are given an integer matrix named is water, which has dimensions m cross n, where m represents the number of rows in the matrix and n represents the number of columns in the matrix, while matrix represents a map of land and water cells. So if a particular cell of the matrix contains 0, that cell is basically a land cell. Otherwise, if any cell of the matrix contains 1, then that cell is a water cell. So what do we have to do in this problem? We are given this input matrix is water. We have to assign each cell a height in a way that follows the rules given in this problem. So we have to return a matrix of same dimensions m cross n, where each cell of that matrix or the answer matrix represents the height for that cell, such that the height of each cell must be non-negative. This is the first rule. The second rule is that if the cell is a water cell, then its height must be 0. And the third rule is that any two adjacent cells must have an absolute height difference of at most 1. We can't have a absolute difference between the heights of two adjacent cells greater than 1. And we know what are adjacent cells. For any cell of the matrix, all the cells present at the left, right, up and down of this cell are its adjacent cells. So we have to return that matrix height, which has dimensions m cross n, where each cell in this matrix is a height. And if there are multiple solutions, obviously there would be multiple solutions, then we can return any of the valid solutions. So in this problem, following these rules, what we have to make sure is that we have to assign heights to each cell such that the maximum height in the given matrix is maximum. So let's better understand the problem statement using an example. So let's take this example. We have a matrix of dimensions 2 cross 2. The cells containing 1 represents the water cells and the cells containing 0 represents the land cells. So for this input matrix is water, we have to return a corresponding matrix height, where each cell of this answer matrix or height matrix represents the height for that particular cell. And we are given that all the cells which are water cells have height of 0. So this is a water cell. The height of this cell is 0. This is the very first rule that we have. The second rule is that the height of each cell must be non-negative, so it must be either 0 or greater than 0. And the third rule is that the maximum difference between the heights of the adjacent cells must not go beyond 1. So let's try to assign the heights for the adjacent cells of this node or this cell. We already have the height for this cell, which is a water cell. Let's try to assign the height for its adjacent cells. So for this cell, which is present at the left of this cell, we can have 0, we can have 1 as well, because if I put 0 here, then it follows all the rules. That is, the difference between the heights of these cells is 0, which is less than 1, and it is a non-negative integer. Same goes for integer 1. It also satisfies both rules. Now which one to choose? Obviously we are going to choose 1, because the third rule says what do we have to return in the answer? We want to maximize the maximum height present in the answer matrix or the height matrix. So out of 0 and 1, choosing 1 would be an optimal option. So I would choose 1. So this would contain 1. Same goes for this adjacent cell. It would also contain 1. Fine. We can store 0 or 1, but we choose 1 for the sake of maximizing height. Now come to this cell. So this cell is adjacent to this cell and this cell. Now it must also satisfy all the rules. So if I put 0 here, then putting 0 satisfy all the rules of the problem statement. That is, the maximum height between the adjacent cells does not exceed 1, and it is also a non-negative integer, but we also have an option to put 1 here, because putting 1 in this matrix also satisfy the rules. We can also put 2 here, fine, because we can see that 2 minus 1 is 1, which does not exceed 1. 2 minus 1 is 1. So the difference between the heights of the adjacent cells does not go beyond 1, in case I put 2 here, and it is also a non-negative integer. So which one to choose? Can I put 3 here? No, because if I put 3 here, then the difference between the heights of the adjacent cells will become 2, which is going beyond 1, which is not allowed. So I can put 0, 1 and 2 here. So which one I'm going to put at this position? Obviously 2 is the most optimal answer, because in the answer what I want to do is to maximize the maximum height present in the height matrix. So I would put 2 here, and that's the answer for this particular input test case. And the maximum height in this heights array is 2. Fine. So how can I solve this problem? Let's see that. Input matrix, we want to solve this problem. We want to generate an height matrix corresponding to this input matrix, which satisfy all the rules of the problem, and the height and the maximum height in the matrix is maximized. So what is the strategy to solve this problem? As we have seen in the previous example, what we did, we first of all we initialized all the cells which contained water with 0. So the cells containing 1 are these cells, this one and these two cells. So I will put 0 for these cells because they are water. What we did for the rest of the cells, we simply explored the adjacent cells of the water cells, and then we kept on exploring all the adjacent cells of the cells which we have already explored. So initially we have explored these cells containing water. Now we'll try to put heights in the adjacent cells of these cells. So I will try to assign height for this cell, for this cell, for this cell, this and this, and then for the cells which I have already visited, I will try to visit the adjacent cells of those cells. So what I'm trying to do, I'm starting to explore from the water cells, and then I am then visiting those cells. I explore their adjacent cells, and then I do the same for those adjacent cells. So this gives me a hint of BFS strategy. So what do we do in BFS? We start from a source vertex or vertices, then we explore their adjacent vertices, and we keep on doing so. Fine. So BFS is a strategy which we will be using to solve this problem. So let's see how we can do that. Okay, so this is my queue. Initially I will be pushing the cells which contains water in this queue. So what are those cells? That is 0, 2 and 1, 0. So the first integer is row number and the second integer is column number. So these are the cells which we initially have while we start our BFS. So we visit these cells, and then I pop the top cell out of the queue, that is 0, 2, which is this one, and I start exploring its adjacent cells, that is this cell towards left of it, this cell just below it. So for this cell which is present to the left of this cell, so what I have to make sure that this cell is unvisited. We have to make sure that the cell is unvisited, and the height that we assign here must follow the given constraints of the problem. What we are given in the problem statement is that, can we put 0 here? Yes, I can, because first of all this is a non-negative integer. The second rule is that the difference between the height of this cell and the source cell, that is 0 minus 0 is 0, which is less than 1, the given height array. So I will try to put maximum height in the adjacent cells while following the given rules of the problem. So the maximum height which I can put here would be 1, and I mark this cell as visited and push it into the queue, which is the cell number 0, 1. Fine. Then I visit this cell, and the maximum height which I can put here by following the rules would be 1, and I push this cell into the queue. This cell is 1, 2, and since this cell has been popped out because we have visited this, now I pop this cell from the queue, that is 1, 0, this one, and I explore its adjacent cells. So I pop this out, and what are the adjacent cells of this cell? That is cell 0, 0, 1, 1 and 2, 0. What is the height or the maximum height which I can put in these cells? Obviously I can put 1 here, I can put 1 here, I can put 1 here, because the difference between the heights of the adjacent cells does not exceed 1. 1 is a non-negative integer, and this is the maximum height which I can put. I can't put 2 because that would make the difference 2. Hence 1 hence 1 is the integer which I can put in the adjacent cells of this cell. And I push these adjacent cells into my queue. So I push 0 0, I push 1 1, then I push 2 1. While this is while while this cell is out from the queue. Now I visit this cell, that is 0 1, this one, and I explore its adjacent cells. We know that adjacent cells of this cell 0 1 are already explored. We have assigned height here, we have assigned height here, we have assigned height here. So we don't have to do anything. So this is skipped. Then I move to cell 1 2, which is this one. The adjacent cells which are not explored is the only cell which is 2 2, that is this one. So what is the maximum height which I can assign here? Since this is 1, the maximum height which I can assign here would be 2. And I push this cell into the queue, and this cell is 2 2. So 1 2 is also visited. Then I visit 0 0, this one, and I can see that the adjacent cells are already explored. So I pop it out. Then I visit 1 1, and I see that the only adjacent cells which is not visited is this cell 2 1, and the maximum height which I can put here would be 2. Fine. So I put 2 here and I push this cell into the queue. So I push 2 1 into the queue, 2 1, and I pop this 1 1 out. Then I move to the cell 2 1, that is, and we know that its adjacent cells are already visited, so we don't have to do anything. So I pop it out. Then I move to 2 2 here. For this cell the adjacent cells are already visited, so I pop this out. Then I move to the final cell, that is 2 1, and we know that its adjacent cells are also visited, so I pop this out, and hence I end up with my empty queue, and here I end my BFS search, and I have my heights matrix prepared. The maximum height which I can put in this height matrix is 2, which is present at the locations 2 1 and 2 2, and I will return this matrix as an answer. So this was just a simple BFS algorithm. I just started my BFS from the cells which contained water while initializing those cells with height 0. Fine. So I hope you got the idea. If you have any doubts in it, please make sure to comment down below. So let's see the implementation of the idea explained here. So this is my highest peak function which takes in this water matrix. I compute its dimensions, the number of rows and the number of columns, answer array, which will be used to store the heights for each cell, and this is my queue. So here I'm iterating over each cell and I'm pushing the water cells into the queue while initializing the answer array as 0 for those particulars, because we know that the height of the cells which contains water is 0, while other cells are initialized with some integer, let's say -1. Fine. So here I'm starting my BFS, and in the BFS I pop the front node, and for that cell I explore its adjacent cells. So here I am moving to adjacent cells. This is the direction vector which will be used to navigate to the adjacent cells of the current cell. Okay, so here n is the length of this direction vector. I'm iterating over this direction vector so as to navigate the adjacent cells of the current cell. So here, so if the adjacent cell lies within the boundary of the given matrix, then, so how I'm iterating here is that the first pair, that is -1 0, moves to the cell just above the current cell. The second pair 0 1 moves us to the cell that is right to the current cell. Then the third pair, that is 1 0, moves us to the cell that is below the current cell. Then the final pair 0 -1 moves us to the cell that is left to the current cell. So that's how I navigate using this direction vector. Fine. And if the new cell is a valid cell, which I am checking here, then I have to check there if the adjacent cell is not visited. So if the adjacent cell contains -1, that means it hasn't been visited because the height cannot be negative. In that case, I have to assign the height to this cell. And how would I assign the height? The height would be the height of the current cell on which I'm standing, which is V. So V is basically nothing but is V, basically the height of the current cell, and I'm simply increasing the height of the adjacent cell by 1. So height of the current cell plus 1 would be the height of the adjacent cell, and this will satisfy the condition or the constraints of the problem, because the height difference between the adjacent cells will stay 1. And since I'm exploring a new cell, I have to push it into the queue, and I'm pushing this new cell x plus temp I, y plus temp I plus 1 into the queue. In this way, I explore all the cells of the matrix, and I maximize the maximum height which can be present in the given matrix. Finally, I have to return this height array or the answer array, which I return right from here. Fine. So I hope you got the idea how this function is working, how I'm performing BFS search to solve this problem. If you have any doubts in the solution, then please post it in the comments. I would reply the comments as soon as possible. So let's discuss the time and space complexity here. The time complexity would be same as the time complexity of BFS, because I'm just performing BFS in this problem. And the BFS in the grid takes big of n cross m time complexity, because I have to visit all the cells of the given grid, and there are n cross m cells in the given matrix. While the space complexity is also big of n cross m, because in the worst case I may store all the cells of the matrix into the queue. So imagine the case when all of the cells of the matrix contains water. So in that case, all of the cells are source cells, and hence the space complexity goes n cross m. I hope you got the analysis of time and space complexity. Let's jump to the implementation part. Okay, so this is the solution class where we have our highest peak function, which takes in this water array and returns the heights array, which is also a 2D array. And so I calculate the dimensions of this water array, and I declare an answer array of dimensions n cross m, same as the dimensions of water array. Then I declare a queue and push all the water cells into the queue while initializing the water cells with height 0. Then I run my BFS search, and in the BFS search I pop the top node from the queue, and I explore all of its adjacent cells here, and for the valid adjacent cells which are within the boundary of the given matrix, I check if they are unvisited. So if it contains -1, then that means they are unvisited, because I initialized my answer matrix with -1, and the heights cannot be -1, and hence they are unvisited. In that case, I have to assign the height to these cells, and the height that I assign would be 1 greater than the height of the current cell on which I am standing, that is V plus 1, and I will push this new cell into my queue. In this way, I will have my answer matrix prepared, and I will return my answer matrix at the end of. So this is how this function is working, and this is the implementation in C++. Let's see the implementation in other languages. So this is the implementation in Java, and this is the implementation in Python language. So that's all for this video. If you like the video, then hit the like button, and make sure to subscribe to my YouTube channel and give your feedback in the comments below. I will see you in the next video. Till then, take care. Bye bye.